Welcome to the webinar covering migrating workloads to a modern data lake with Starburst Enterprise. I'm Dan Catalupi. I'm a product manager on the Starburst Enterprise product. And just a little bit about me is that I've been with Starburst just short of 2 years now. And prior to joining Starburst, I was involved in the healthcare and cybersecurity industries, working with a number of different data sets. And so I'm here joined by my colleague, Russell Christopher, who I'll give a minute to introduce himself.
Hey everyone, I'm Russell Christopher, Director of Product Strategy. I too have been with the company just about 2 years, a little bit more than that. Before that, I guess I've always been a data person. My first adult job was with Microsoft, actually supporting Microsoft Access and then SQL Server billions and billions of years ago. Was with Microsoft a long time, then early on at Tableau, also with Alteryx and a couple startups. And now I am super happy to be here and again, still doing my data thing. So Dan is going to take it away. I would invite during the presentation, if you have any questions, feel free to use chat. I will answer those questions as I can while he is talking. And then while I am talking, he will do the same thing. So Dan, back to you.
Thanks, Russell. All right, so let's talk about what we're going to cover today. First of all, we want to just give a brief overview of Starburst. And from there, we want to share some of the findings from the GigaOM analysis, comparing Starburst to Snowflake in terms of total cost of ownership. And I think it'll be a good segue into talking about what makes up a modern data lake that we reference in the title of the presentation. And then we'll finalize it by walking through how Starburst excels for every stage of the architecture journey that you might be on. So jumping into it, at Starburst, we strive to make data accessible and simplify data architectures. Starburst allows you to access all of your data, no matter where it lives, whether it's in a cloud data lake or a NoSQL store like MongoDB, or even if it's in an application like Salesforce, we can connect to it. And through those connections, we can help democratize the data for analysis, providing fastest time to insight. So no longer does it live in there and you have to use that solution to query it. You can use Starburst to query those sources. And we know that data needs and architectural requirements are constantly changing. So Starburst can help manage the chaos. With federation, the goal is not necessarily to build the most efficient ETL pipeline, extract, transfer, load pipeline, but instead is to get access to the data that you need when you need it and generate the insights to drive your business as efficiently as possible. So based off of the open source Trino project, which is a massively parallel processing engine, Starburst adds enterprise-grade features and connectors to help customers manage and optimize their performance, their cost, security, and generally just making it easier to deploy and consume your data. So holistically, Starburst Enterprise, with Starburst Enterprise, you are in control of your future. You can build the data architecture that makes sense for your specific use cases, and you can increase data access to various cross-functional teams in your organization through this single platform. So let's get on to the GigaOM analysis that was released a few weeks back. It's a comparison of the total cost of ownership for deploying, migrating, and managing Starburst on the data lakehouse to Snowflake's data warehouse model. The analysis was made up of 4 key use cases that evaluated migrating data to Snowflake for analysis against various combinations of data migration and federation for Starburst analysis. All use cases took into account both structured and unstructured data, so that it was just compared one-to-one. So if I were to set the scene, we have structured and unstructured data in the cloud and on-prem that Snowflake, in the Snowflake analysis, had to be migrated. All the data had to be migrated, staged, loaded, and transformed into Snowflake to even run that first query. So the analysis didn't only just take into account the transformation, duplication of the data, and then the actual analysis on top of that migrated data, but it also took into account the effort and pay for the teams that had to perform that migration. Then, we identified that the migration can be costly, but the findings also identified that costs can also lie where some queries run with Snowflake required much more compute than it did for Starburst. Conversely, I'll just use one of the Starburst examples. If we set the scene for Starburst, there's reduced amount of migration. So if I wanted to move data, both unstructured and structured data, from a legacy lake to a modern data lake and just federate that on-premise data, then we're minimizing the migration and we're leaving this on-premise data as is, getting insights faster than we would have with a cloud data warehouse solution like Starburst. So this analysis ultimately revealed that Starburst can save up to 45 to 55% in total cost of ownership. And then it could also circumnavigate significant migration efforts. And then it will realize 90% faster time to insight than it could with other solutions like cloud data warehouse, like like Snowflake. So the question remains is, how can we utilize Starburst to unlock those cost savings that we're pointing out here? I think it's worth taking a step back to really understand what makes up a modern data lake that we're referring to here. On the previous analysis, I mentioned it said Starburst on a data lakehouse. Well, a modern data lake is part of the data lakehouse story. It all starts with separation of storage and compute. As your organization grows, the collection of your data is going to grow. So being able to scale up and down your storage is extremely important. And cloud providers can offer that very easily with the toggle, right? Separately, they have been able to separate compute and allows customers to utilize features like auto scaling to meet the demands of your users at critical moments. So when you see increased queries activity on a cluster, that cluster can scale up and scale down as needed. And the key to this is that you can toggle each of these independently without affecting the other. The next layer to the modern data lake is the choice of file format. And this is important because you got to consider the use case that is important for your scenario. So whether it's row versus columnar based, you can use Avro for heavy write workloads with schema evolution, or you can use ORC for maybe a Hadoop or Hive data storage, or even Parquet for also data lake storage, and heavy read use cases. What we've been seeing is that Parquet is a very reliable data lake storage format that's highly efficient, has highly efficient compressibility. So it's reducing the storage size, and it's faster for query processing due to its parallel processing capabilities. And so these decisions make an impact on how your query performs when run. Similarly, we want to ensure that we're choosing the right table format. So table formats being just a way to store the data landing in the lake in a format that's accessible and interoperable across, analytical tools. It's essentially standardizing your data across systems to use that same blueprint, right? And it introduces structured database-like features to your data lake to make it a little bit more easier to find the data and analyze the data that you have stored in there. And also, like file formats, the use case will significantly determine the query performance, efficiently utilizing metadata to point to where the data lives. So whether you want to have for data pipelines, you might look at Delta, or analytics and schema evolution, you might look at Iceberg, or maybe real-time processing or streaming analytics, you might look at Hootie. So overall, the components of this data lakehouse, or otherwise known as what we're calling a modern data lake, are highly toggleable. You can control each part of it without affecting the other. Now, why do I make the difference between, before I get into that, there's one key component missing here, and that's a query engine. So that's what leads me to open source Trino, which, as I mentioned, is a massively parallel processing engine. It's widely used by some of the largest companies in the world, and they rely on it for processing large amounts of data, petabytes worth of data. But these companies have the resources to be able to manage a solution like this. Trino does not have management capabilities or any security. You have to typically rely on third-party RBAC solutions, role-based access control. And if you ever have an issue, there's no support that you can fall back on for those needs. So that's where Starburst comes into play. Your organization can address the most challenging workloads and use cases with Starburst Enterprise because it offers a single point of access of governance for all data, brings advanced warehouse-like capabilities, is vendor agnostic, scalable, and cost-effective. It builds on the Trino open source to offer proprietary features that makes it a future-proof solution. As your architecture evolves, our solution adapts with you. And federation is a key part of that. You have the flexibility to move to the modern data lake or try a proof of concept while maintaining other architectures, the data architectures. And as I mentioned before, there are proprietary features that can really accelerate your experience with querying the data lake or other sources and federate between those. And then the cherry on top is being able to build out the data mesh that make data accessible to your data consumers. So we'll get into some of these later on in the presentation. But I want to tie it back to the Lakehouse, right? Starburst builds on top of the Lakehouse that makes up a modern data lake. There are 5 key components to a modern data lake, and that's separation of storage and compute, open file and table formats, a high-performing scalable query engine, fast, easy, federated access to data outside of the lake, and seamless connectivity to BI tools to be able to roll up those business insights. So Starburst and the modern data lake provide an open approach to data management that reduces total cost of ownership, promotes flexibility and faster time to insight, and prevents vendor lock-in. Okay, so we understand that no architecture is absolute. There are weak points of the modern data lake that may lead you to keep data in other sources for efficiency or cost of or performance, right? However, the Starburst platform is designed to take that into account. It's built in a way that makes querying the modern data lake as efficient and cost-effective as possible. And when the use case does not line up exactly, additional features exist to maximize performance on external tables to be federated with the data on the lake. So ultimately, the goal of many of these improvements is to deliver as close to a data warehouse experience, but with your data on the lake to reduce overall cost. All right, so as I've mentioned, we referenced a number of proprietary features, and I want to get into sharing some of them today that are relevant to this conversation. The first and foremost is warp speed. Warp speed is a proprietary index and caching technology for object storage data to improve cost efficiencies and performance. So what that simply means is anytime a user runs a query, it'll intelligently index and cache parts of the query for later reuse. And later, let's say user 2 were to run any query, that query will be analyzed to utilize any other components of previously run query. And there will be popular components of the query that will be reused more commonly than others. And so it can use a combination of indexing and caching to accelerate parts or whole parts of the query to deliver cost savings and increased performance. Next, I want to introduce you to the Snowflake Parallel Connector. The connector has been parallelized to optimize for query performance, while querying Snowflake, the Snowflake database. It sends queries to Snowflake for execution and then reads those results independently from different nodes in parallel. What it means is it's fast, right? Snowflake Parallel can be used to offset the expensive compute from Snowflake if you just want to start easing off of it, or it can be an efficient way to just simply democratize the data that lives in Snowflake, right? If you want to be able to federate data in Snowflake with something else externally, Starburst is there. The next thing I would like to talk about is managed statistics. This is a neat feature where it's a feature set that solves for the connectors that offer only partial or no stats at all. If stats are not offered natively, then users can run a collect stats on a table and store them in SEP for query engine optimization for the next time. That query optimizer will then improve upon the query plan to optimize the execution and how it retrieves those query results. So ultimately, it's just that minor boost or up to a major boost, depending on what type of query you're running, to just really get the most out of your engine. All right, along the same theme, we're talking about performance improvements. We have table scan redirection, which is a performance feature that materializes data from one tier of your architecture closer to compute for easier access. In other words, when a query is run, I might try to hit one table, external table, and we might have a materialized version in the lake closer to compute that it will actually redirect my query to for faster and more cost-effective access. And so when that happens, we actually notify the user in the query history details. And every time redirection is executed, it's executed after applying authentication and permission checks from the sources catalog. All right, there's a couple future features that we are looking to target for the new year. And the first of which is response cache. So contrary to warp speed, where it can accelerate parts of the query, response cache is an all or nothing approach. It finds matching queries against previously stored hashes to return results from the cache for optimal performance. So how it works is it has to be the same query and has to be the same results for the results to find the match and pull the results. It's great for things like dashboards or commonly run queries where you're constantly running those same queries over and over. All right. And the last one I'd like to talk through is smart pass-through. It's an intelligent capability that identifies when a user is submitting a query to a single source. When that happens, it just decides to push the entire query down to the source for optimal performance and minimizing costs. Pushing down parts of the query and keeping some locally can vary in cost. So by pushing it down, we can try to achieve the closest thing to native performance. All right, so that brings me to the stage of the journey you're on. We've covered the basics of the modern data lake, and we've discussed the components of Starburst that helps unlock the performance and cost savings. But now Russell will get into how Starburst can utilize, how you can utilize those Starburst features with different architectures to maximize the value depending on where you are in the journey. So Russell, over to you.
All right, awesome. So this is actually my favorite slide in the whole deck. I love the rocket ships flying all over the place. I guess it's my inner child. But the one thing I want to point out about this slide is that this is not sort of a one-way linear journey. You don't necessarily progress from one place to the next, to the next, to the next. Sometimes you're moving forwards and backwards. Sometimes you're skipping steps. And in fact, these sort of labels that we've applied to a place, a state somewhere on the journey are somewhat arbitrary. They're just kind of convenient places to hang some discussion about where you may be and where you may be going. So enough said on that. Let's actually head to the next slide, Dan. And we're actually going to start off in why don't we call it legacy land? And there's a lot going on here, but we'll start with the legacy DWs. And to me, a legacy data warehouse is probably most identifiable, for lack of a better word, by the fact that it's a gated resource. Unlike a Snowflake or a Redshift or a Cloud DW, if I have a user who issues, I think we're all friends here, so I'll just say it, like a dumb query, no magical extra compute is going to show up and help that thing finish in a reasonable time frame. So these are often very expensive to run on legacy DWs. A runaway query, especially, it's going to have real measurable impact, not only on your bottom line, like dollars and cents, but on user experience. If you want to make a Teradata DBA like freak out, just fire select star from foo, or just try and build that bazillion row extract in Tableau. And they're going to be knocking on your door, or those queries are going to get killed like lightning fast. So when you're dealing with these types of resources, you need to really meter your access. You need to execute your queries in a really efficient way. You need to cache and you need to reuse what you can. And Dan already kind of went through a lot of our purpose-built capabilities to make that work well for you. I'll call out a few that I think are more applicable than not. The table scan redirection, for example, he mentioned. Let's make sure we have a local cache of data, if possible, close to local compute, rather than having to go out there and hit Teradata or Oracle or whatever the case may be over and over again. The response cache is great. That's like old school. Someone else asked this question, so here's the answer. And then my favorite is managed statistics. I love data, and I love making query optimization even better and smarter by giving it the data it needs. That's exactly what managed stats does for you. So this is going to sound a little bit like sort of older school data virtualization to a certain extent. You've heard us say federation quite a few times as well, and we'll continue to use those words. I want to editorialize a little bit that, if anyone ever tells you like our technology is perfect in that regard, then, I have a bridge to sell you, because the goal here isn't really to out DB2 at DB2 query optimization, right? They've been doing this for a long time. It's an awesome query optimizer. That said, Starburst is better than pretty much anyone else that out there in terms of doing this sort of workload. So the reason why I say that is you're probably going to be federating your DWs against your lake. Since folks have discovered, sometimes painfully, there's no one size fits all. You can't do everything from the lake. You can't do everything from the DW. You need both. You're probably also going to deal with multiple centers of data gravity. So we're going to kind of talk about legacy lake a little bit. I'll define that in my mind. It typically means I'm doing Hive and I'm doing HDFS. So maybe I have some raw Parquet out on HDFS, or I might just have files. I might have some JSON or CSV or whatever. You may actually choose in this journey that we're talking about now to eventually move some of that data out of your legacy lake, maybe into Iceberg on S3, let's say, on object storage. Or in some cases that data actually might just sit there in your legacy lake until like the heat death of the universe, because it's just valuable enough to keep around, but it is not valuable enough to migrate. And if you go that direction, like that's totally cool, right? You just need to be able to integrate that data without moving it, and also be able to onload new sources that are coming down the block later. And that's where we really shine from a federation standpoint. So you're going to get immediate value in terms of being able to cut your time to insight, because you query these sources where they live. You federate that data instead of migrating it, or at least being forced to migrate it. So a basic example might be you have tons of data sitting in Parquet. You want to actually join that to maybe some master data that's sitting out on Teradata. And then you also have some raw JSON somewhere. And normally you'd have to like flatten that and load that somewhere else. In our sort of a scenario, you don't bother. just join that into, and away you go. So that this next bullet, it's the third bullet on the slide, is one of my favorites because I'm sort of an inveterate tinkerer, I guess you could say. The platform itself, Starburst, can act as, I guess you could call it like a Dexter's laboratory, in terms of a safe place to get a level of comfort with all of the wonderful new toys that people are just constantly coming up with in modern data lake. So maybe you've never had a good place to tinker with Iceberg or Hootie or Delta or whatever the case may be. Well, we got you covered there. And it feels like at first maybe an ancillary benefit, but in terms of progressing your skills and moving your data architecture to a more open standard, a more modern standard, it's actually pretty important. The last thing I'll mention on this slide, and you can kind of see it right there for yourself, again, begins hitting on federation, but extending that into consumability. And typically that means folks want to provide data products to their end consumers. And you'll tend to do that via some sort of a data architecture like data mesh or data fabric. We enable both of those data architectures. And we even have, we won't talk about it a lot today, but we even have a feature called data products, which is essentially going to allow you to create and share just very highly curated data sets for mass consumption. So the top line, when we're talking about legacy land, Starburst makes what you already have more accessible, more curated, lets you derive insights from that data more efficiently from a cost and performance and maybe time to value angle. So let's go to the next slide and kind of move to the next step here. All right, so now we're in cloud data warehouse land. And this is kind of starting to get fun because if you combine the Starburst platform with existing cloud data warehouses, you're already beginning to look a lot like a modern data lake, or at the very least, you're, I don't know, like modern data lake adjacent, I guess you could say, because it looks like a duck, it swims like a duck, it quacks like a lake. So you're getting pretty close, even if you still are focusing very, very heavy on your cloud data warehouses. Now, one thing that the slide itself calls out is the fact that we help you activate the true value of your object storage. And what does that mean? I'll give you a before and after in terms of the way I think about it. But before technologies like this came along, your S3 or your blob storage, whatever it might happen to be, really was just kind of acting as new HDFS, right? A lot of people just use this stuff as a place to stage and land data before they loaded it into a Snowflake or a Redshift. That's kind of all it did. But once you bring Starburst into the picture, it's a different world. You have faster time to insight because you might choose to just simply report against or execute queries against the data right where it lives on S3. You skip the pipelining, you have fewer moving parts, you have fewer tools to deal with. So that's going to lower your cost. That also typically means less data duplication. And then again, for me, the best part of this is you have more options in terms of different data architectures and actually being able to solve your data problems in different ways. I'm going to use the F word again and say federation. We help with really higher end federation as well. Dan, for example, mentioned the Snowflake parallel connector. There are situations where you may need to pull a lot of data out of Snowflake to answer a question, especially if you have to do that at scale. You want to do so in a super efficient manner, and we get you there with the parallel connector. Or maybe on the complete opposite end of the spectrum, again, you have your smart pass-through. You want to take a query as is, not even allow our query optimizer to look at it. You just want to throw it at that data platform, let the data platform figure it out, and get just your few aggregated answers coming back as a result set. The only other thing that I'll say on this slide is we are SQL based, right? Everyone knows that. That's our claim to fame. Everyone likes SQL, but we kind of love Python too. And we won't talk a lot about that today, but if you're a fan of Python, there's a lot of good stuff landing that will allow you to take advantage of our modern data lake programmatically, maybe using muscle memory that you've built up over the years using libraries like PySpark as an example. Okay, so let's go to the next slide. We're now going to just cover off on a couple sort of semi-random things around migration. For me, the most important thing on this slide is that Starburst is going to help you avoid those big bang migrations that take 18, 24, 36 months, are high risk, are very expensive. Instead, what we're going to allow you to do is sort of rebuild the plane while you're flying it, and instead shift to a more transparent, modular, maybe you want to call it granular lift and shift of data assets from legacy land to modern land without your users really even realizing what's happening. You just flip the switch on the day certain things have been moved and you get on with your life. One other thing that a modern data architecture enables, especially now since a lot of the cloud data warehouse vendors are sort of reading the tea leaves and beginning to support some of these open formats like Iceberg, is actually how you load your data warehouse. And what I'm talking about now may not even really belong on this slide, but it's interesting. So I put it in here. If you are running a modern data lake, if you're focusing, let's say, on the Iceberg table format, really all you need to do is expose that to these cloud data warehouses. So when you load your Iceberg tables, which you need to anyway to make them available to the rest of the world, you're actually acting as the storage for these cloud data warehouses. That, I think, again, is really cool because it's less work for you, it's fewer tools, it's lower cost, et cetera, et cetera. It gives you more flexibility. All right, Dan, let's head to the next slide where we have sort of reached nirvana theoretically. We now are enlightened. We understand all things, and part of that is embracing the fact that your data architecture really needs to be decentralized. It's that way by default, whether you like it or not. You know, the whole single version of the truth, that's cute sounding, but it's very difficult to do. You have lots of moving pieces. So if we go to the next slide, you begin to realize that the marketecture slide that Dan showed you a little bit earlier, well, maybe it wasn't a lie, but how about it was gross oversimplification. In no world I've ever seen do I have like my lakes neatly next to my old legacy HDFS and all of my databases just really easy to access. Instead, it's going to look something more like this, where I maybe begin in my on-premise world, and that's where my old Hadoop is and some of my legacy DWs. And now I have to think about this new environment. Maybe that's what my cloud is going to be. And I decide, well, I'll use ADLS, we'll use Azure, and that's where my storage will be. And sounds great, but oh my goodness, I have this other cloud that I didn't really think about. Let's go to the next build on that. And this scenario, I'm only showing it to you once, but it's not unlikely this may be going 2 or 3 times. And what happened here is like 2 or 3 years ago, some guy thought like, I'm just going to stand up a couple warehouses on Snowflake or spin up Redshift or do BigQuery. And then, of course, you need to feed that beast with data, which means you're now using object storage. And then over time, people start throwing like their cast off, Parquet and CSV and JSON. And all of a sudden, you're developing these sort of wannabe lakes all over the place in secondary and tertiary clouds. So how do you tie this stuff all together? Well, you know what I'm about to say. This is a Starburst webinar. What we would suggest is in your primary cloud, you're going to go with Starburst as your primary analytics engine. Now, the beauty of using open standards, of course, like if you're using Iceberg here, is you can also bring other tools to the table. If you love your Spark, bring your Spark. It'll work just as well, and we complement each other. Now, over here in on-premise land, you're probably going to have a smaller Starburst cluster to get at that HDFS or that MapRFS stuff that you still have lying around, as well as your legacy DWs. And then over here on your clouds, you may want to use the fully managed Starburst Galaxy. This is our pure SaaS offering. This is perfect for this sort of work. Finally, you need to knit all of these environments together. And that's where we really shine. We have a capability called Stargate, which essentially allows all of the clusters, no matter where they are, to communicate with each other. And then the really important thing is governance, right? Each one of these environments might have dramatically different governance and policies and data sovereignty rules, and all of that stuff needs to be honored and obeyed by anyone who consumes the data, no matter where they are. Stargate lets you do this. So to me, this is actually the modern data lake. It's distributed, it's purpose-built, it has compute close to the data, yet you're able to bring it all together and treat it as essentially a single point of access from wherever you happen to be. Okay, that was a mouthful. So let's move on to the next slide, which I believe, yes, it's the obligatory closing slide. We are legally obligated actually to have a closing slide here. So, if you take nothing away from the presentation, but the following, you're probably in a good place. Think about Starburst when you're thinking about cost and flexibility and optionality. That is where we really shine, because we give you federation. The federation allows you to choose, if we're thinking about a TCO type question, whether or not you want to migrate everything or pieces or less of that. Finally, because we focus on optionality and flexibility, we really do future-proof your data architectures. And finally, I suspect everyone on the call already knows this and you've already been convinced, but I'll say it again in case you don't quite believe yet. Data architecture is distributed these days. Like, deal with it, plan for it. And a modern data lake using technologies like Starburst and Stargate is a really, really good way to go after that problem. So that's it. I think we're actually done. I don't see any questions in chat. If you have any, feel free to ask in chat. We'll hang out for a minute or two to see if any land. Otherwise, thank you very much for being here and listening. We appreciate it.